reveals. Well, I picked up this motor. I was going to get this terminal cover off and use it to fix this motor up. But it turns out I think it's got a smaller footprint. It might fit. And on the second thoughts, I did test it, and it tested okay on the Mega. The windings even look okay. They don't even look like they're burnt, so this motor might be fine. I think the white was saying in the bin because it had water in it, and I could see why because I couldn't turn it. Okay, maybe the bearings are seized. But no, the bearing's fine. Now look carefully in there. The rotor is rusted to the stator. She got hydro locked. The motor obviously wasn't running for a long time and it just rusted solid. That's it. Nothing the wire brushing can't fix. It's a Mechtric supplied motor. Generic Chinese thing. But it's that design that CMG use, where you can bolt angle onto it and make it a foot mount. Which would be a bonus because I can put a big fan on this, or put a guard in it, and this would be a good candidate for a fan conversion. I'm going to get the paint off to go with the specs off this plate. It's a 0.75 horsepower, same size as that one. Actually, I wonder if the bell housings on that will fit on here. Oh, I can't. But I could... No, they won't because the rotor might fit there. That will save this stator assembly because that one there is good now. But should it burn out, then this rotor will fit inside this one. And I could bolt those feet somehow, if they're the same, depending on how they're mounted, bolt them onto here. And make this a foot mount with a flange on it. Anyway, it's always good to play with and have some handy dandy 3-phase motors. I'd love to get some more old ones like this. These things sound nice. They're just such a joy to restore. Love to get a propulsion style induction one. They're hard to find though, and expensive when you do find them, or like online and everything like that. But these things came out quite well. It's all fixed. So, as I said, should it burn out, I've got the another stator with good windings. It's too hard to pull that out and press it into that. Just too much work. Anyway, let's continue to pull this motor apart and free it up, and I can give this thing revving up on the VFD. Itching to be revved up. Motor's fine. It actually has copper windings too, not aluminium. Just had water in it, and she's rusted solid. Give it a good clean out, and that's it. I don't see any burn mark in the windings though, so nothing melted. Anyway, the vacuum cleaner out and just clean up this excess dirt, and we can put this in, clean this up and sand that up a bit, put it back together. And if it does scrape even a slight or swell, nothing a heap of friggin' revving the crap out of it isn't going to can clean out. Then we'll get it back and freed up. So I said both those bearings are fine. I got the long midget set up. I've plugged the VFD in. I've got the earth hooked up on this one. Ready for a test. I'm gonna. This is what I don't like about bench testing flange mount motors. They're gonna go walkie-walkie. That's why I prefer foot mounted motors. They tend to stand up and not move. These ones just roll all over the place. What have I got it set to here? 100 hertz. Let's go to 10 hertz. Nothing wrong there. 20, 30, 40, 50, 60, 70, 80. Oh, this motor doesn't need to be programmed by the looks of it. This motor needs to be programmed big time. Okay, the parameters are different on this motor. That's 50 hertz, 55, 60 hertz, 65 hertz, 70 hertz. 80 hertz. Reverse. Okay, let's go reverse. Wow. First matter I've come across where I'll have to change the parameters of this drive to get working. Hertz is fine, anything higher than that. Oh, I can't go over 80 hertz. There we go. Running on 80 hertz. But I can't go past 80 hertz, this motor doesn't like it. What a shame. Clean that shaft up. Right. There we go, clean that dirty shaft up. This motor is obviously different altogether than the other ones. The other ones just seem to run fine up to 200 hertz. This motor is a bit more stubborn. Sandpaper on that shaft. Okay. No, I don't like it. Got to manually do it back to that speed now. Okay. Weird how that some motors do that. This motor is just different. Huh. Different to the other motor. I thought it was identical to the other one, but no, it's just different. Let's see if I can go one by one increments. Hertz. Yeah, 90 hertz. My new record on this motor. Bearings are good. Hertz. Oh no, motor slip. Oh, wait, we're on 100 hertz. Oh, not quite 100 hertz, but I made it to 95. As soon as I got past 95, she started to slow down a bit. This motor is way different to set up. Way different to set this motor up. But she's got good bearings in it, that's for sure. I'd have thought, because it's an identical motor, horsepower wise, but it's not. Yeah, the shaft got a bit of heat induced into it, so yeah. Normally when it does that, you get a lot of slip, that's inducing heat in the rotor, so that's not necessarily good for your motor. Just make the induction heater out of it. But she works fine. Just got to put a cover back on it and seal it up so I can wash it. That thing's filthy. I had to cut the screw off because it was just so stuck. I had to sacrifice the gasket to get that off, but it didn't damage anything other than the gasket. So I could draw that out. And that's it. I'll put these screws in that lid. But she's actually come out quite well. Not bad for a matter that was just stuck by rust. Yeah, by rust, that's all it was. But this will come in useful. More motors to play with. Electric motors are always good fun to play with. Very handy to for little experiments. I've got some more things I could use to drive them too. So I've got some pumps and other things I can drive now. So more things to play with. Anyway, that'll be enough for now. Thanks for watching.